I'd like to officially welcome you to the 2022 Edith and Peter O'Donnell Awards dinner. Thank you for joining us tonight. It's been some time since we've been together like this, and it's quite special. So I hate to intrude on your conversations, but we do want to go on with the program. We'll have time after the program tonight for you to continue to socialize. And please note, the bar will be open until 10 p.m., I believe. So we'll try to get you done in plenty of time to complete your socialization. Well, tonight, we'd like to take a moment and to thank our sponsors for their support of this conference, especially our platinum sponsor, Briar Capital. So thank you, Briar. We're also grateful for the support of the Oscar Fisher Prize and their special sponsorship of this event. And tomorrow at the conclusion of the conference, we'll have a special ceremony honoring the inaugural recipients of the Oscar Fisher Prize. We'd also like to thank our diamond sponsors tonight, Texas A&M University and UT Southwestern Medical Center, Southwestern Medical Foundation. Thank you for your support. And TAMEST would like to thank the donors to the TAMEST Endowment and the O'Donnell Endowment who are in attendance with us tonight. That would be Mr. Jeff Kodosky from the Kodosky Foundation. Thank you, Jeff. And tonight we are honored to have with us Senator Kay Bailey Hutchison, Larry Faulkner, and Kenny Jastrow for their work on establishing the TAMEST Endowment. Thank you all very much. And perhaps most importantly, we'd like to thank the O'Donnell Foundation for making this program possible this evening. This ceremony is unique. It's not often we get to gather with so many different Texas research organizations and so many members of the research community. With us tonight, we have university presidents, chancellors, CEOs, and many, many distinguished scientists and researchers. And we can see the next generation of Texas top scientists, engineers, and researchers here tonight as TAMEST members invite them to attend as part of our Protégé program. We're very pleased to have the 2022 Scripps Spelling Bee champion, Harmony Logan, and her family here with us tonight. Where are you? Where? Ah. Congratulations, and thank you for being here tonight. What a great award and recognition that is for you and your family, so thank you for being here. This evening, we are here to recognize and celebrate our rising stars in research, the recipients of the Edith and Peter O'Donnell Awards. The Edith and Peter O'Donnell Awards recognize rising Texas researchers who are addressing fascinating scientific and technical questions and whose work meets the highest standards of exemplary professional performance, creativity, and impact. The awards represent a way to recognize younger researchers at a critical stage in their careers and raise the profile of what's being done in our great state. Since this program began, 15 O'Donnell Award recipients have been inducted into the National Academies of Science, Engineering, and Medicine, so we can really pick them. With us tonight are several past recipients of the Edith and Peter O'Donnell Awards. If you are a past recipient, please stand at this time and be recognized. Congratulations to each of you again, and thank you for being with us tonight. One thing that makes the O'Donnell Awards special is that the winners are selected by National Academy members in Texas and approved by a panel of Nobel laureates. It's a highly competitive, prestigious award, and tonight we celebrate both our new and past recipients. We'd like to recognize the 2022 Awards Committee, chaired by Ms. Ann Salamone, for their hard work identifying these outstanding candidates over the past year. We'd also like to thank the Nobel Laureate Committee, chaired by Dr. Joe Goldstein, for their service in reviewing the finalists for these awards. And as you probably already know, the awards are named in honor of the late Edith and Peter O'Donnell, who were among Texas's most devoted advocates for excellence in scientific advancement and STEM education. The awards showcase the best and brightest in Texas research whose creative work could have a lasting positive impact on all of our futures. I would now like to invite the Honorable Kay Bailey Hutchison to share a few words in remembrance of Edith and Peter O'Donnell. Senator Hutchison.
Well, thank you so much, Adam, and thank you for all you have done to help make this wonderful night just perfect. We are celebrating, and Edith and Peter O'Donnell wanted exactly what has happened with the Edith and Peter O'Donnell Awards. They've had a tremendous impact in bringing the best and brightest to our state and celebrating them. And as I mentioned this morning at the breakfast, the Nobel laureates that put together the framework for TAMEST said they loved the idea of an award for the best research that's being done in Texas. But they didn't want any TAMEST member to be eligible to win it. They wanted the new young leaders to come forward. And that's exactly what's happened. And as Adam just mentioned, 15 of the awardees have become members of the national academies, which was one of the core reasons for starting TAMEST. Peter and Edith O'Donnell were among the most special people I have ever met. They had the vision that helped form TAMEST, and we all called Peter the godfather of TAMEST. Tonight, I want to take a moment to remember them because they have made such an impact, each in their own right and then together. Edith O'Donnell passed away in November 2020. She was a beloved humanitarian and a passionate supporter of scientific research and the arts. Her philanthropic work will have an unmatched and lasting impact. She funded something that was the closest to her heart, and that was the new building at the University of Texas at Dallas called the UTD Edith O'Donnell Arts and Technology Building. And she wanted both. That's right. Peter was one of Texas' greatest citizens. He passed away last October, and he was the champion of philanthropy in our state. His passionate support of scientific research, education, and the arts will leave a lasting impact. But there's one other thing about Peter that I know personally because I talked to him about this. We used to have this little sort of well-known secret in Dallas that every charitable event that ever happened had a big anonymous on it. And we all knew it was Peter O'Donnell. And I talked to him myself, and others did as well. And it came about right here with TAMEST. When we started talking about the awards, and it was his idea to have awards that had a significant financial component for these scientists that are scientists and doctors and engineers designed. He said no, we couldn't name it for him. I said, Peter, think of this not about you, but think of if it has your name, that will be a prestige of the award that will go on for the lifetime of the winners, and it will encourage other people to be generous as you have been. And he finally came back and said, okay, I'll do it. And from that time, and it was started here, from that time, he allowed, and Edith did, the other things. It was the Edith O'Donnell building at UTD. They would never have done that if they hadn't started seeing that this was even more of a contribution. So we started something really big here to bring the list of people that showed up on that screen for the endowment of TAMEST was because the leader was Peter O'Donnell. So the gift keeps on giving, because I will announce tonight that the O'Donnell Foundation has agreed to add one more award. They are making a $1.5 million gift to TAMEST to expand the O'Donnell Awards to create an additional science award. So the awards will now recognize recipients each year in the categories of medicine, engineering, physical sciences, biological sciences, and technology innovation. So the last great thing that Peter O'Donnell did, let me just say that I went to his memorial service, and they had the pictures of the key things in Peter's and Edith's life that were their most important contributions that they did so much to produce. And TAMEST was right there in the group that went through time and again. So he was proud of this. And the last thing he gave us was a foundation that would keep going, that would continue with the priorities that he had set, and that will include TAMEST for a long time to come. So tonight we honor Peter and Edith O'Donnell in the way that we can by doing exactly what they wanted and looking at the great people that are going to get these awards tonight. Thank you.
Senator Hutchison, thank you for being here tonight. It's an honor to have you here and to hear some of that insight from you on Peter and Edith both. And thank you for this great award. We are thrilled about this new gift from the O'Donnell Foundation, and we'll make sure it is put to great use. Now it's time for this year's awards ceremony. Each O'Donnell Award recipient will be introduced by a video highlighting their work. We will then hear remarks by their nominator, followed by remarks from each award recipient before they're presented with their awards. So tonight, we'll start with Jason McLellan. He is the recipient of the 2022 O'Donnell Award in Medicine. Dr. McLellan is the Welch Chair in Chemistry and professor in the Department of Molecular Biosciences at the University of Texas at Austin. Let's learn more about him and his work while all of our nominators and awardees come to the stage and take a seat. Thank you.
You never know when inspiration strikes and where the ideas come from. Being creative as a researcher is really able to come up with the question or come up with the problem. That's usually one of the most exciting days, not necessarily when you solve it, but when you create it. I'm a structural biologist. We determine three-dimensional structures of proteins. We want to know precisely where every atom is in these macromolecules, how the amino acids that make up the proteins fold, how they function, how specifically do they bind to receptors on the surface of our cells. With the structural information, we get to engineer and make the best possible forms of these proteins to use as vaccines. We've been working on coronaviruses since 2013. So when SARS-CoV-2 emerged, we immediately knew within hours how to stabilize the SARS-CoV-2 spike to make the best possible vaccine antigen.
So we all by now, I presume, have seen these images of the coronavirus, which are sort of a wide sphere with red spikes.
The virus uses that to attach to our cells and then fuse the virus membrane with our cell membranes and ultimately infect the cells.
If you're able to stabilize the pre-fusion state, that means that when you immunize with this stabilized protein, it generates antibodies that are called neutralizing antibodies because they are protective and they're neutralizing. They're valuable against stopping the infection.
The pre-fusion form is the better vaccine immunogen. It's what's on the surface of the virus. It's what we want to train our immune system to recognize and make antibodies and defend against.
So many things came together to make this possible. One of them is the advances in structural biology, and that's where Jason is an expert.
By March, there was already the first humans being vaccinated with mRNA vaccines encoding our stabilized spike proteins.
Jason's just a superb scientist who not only was at the cutting edge of understanding viral mechanisms, but also how to design vaccines at a time when vaccine design has made a huge difference in the world.
We and others are applying structure-based vaccine design to develop vaccines for many emerging and re-emerging pathogens. It's exciting to see the impact we're able to have based on research in the lab. We all hope in the sciences that maybe one day we can have some impact on human health. It's been really gratifying to see the effect that the vaccines have had on so many lives.
Dr. Leahy, would you come to the podium and introduce your nominee?
Well, it's a great pleasure to introduce my colleague at the Department of Molecular Biosciences at UT Austin, Jason McLellan. Jason grew up just outside of Detroit. He was a first-generation college student at Wayne State University, where he was a summa cum laude graduate with degrees in chemistry and biochemistry. From there, he went to Johns Hopkins University School of Medicine, where he pursued graduate studies in structural biology, as you heard, and he made some very key discoveries about the molecular mechanisms and structures of molecules involved in the development of complex tissues in animals and higher organisms. And I was on the faculty at the time, and I remember him, because we all know our super students, saying, you know, this is all very interesting, but I really want to do some science that really relates to human health. And so he then moved on to a postdoc at the Vaccine Research Center at the National Institutes of Health to work with Peter Kwong, whose lab was pioneering efforts to use structural biology, but looking at the structure of the molecules on the surface of the HIV protein and how the rare neutralizing antibodies bound to those structures to try to develop vaccines against HIV. And Peter's lab was popular, hard to get into, but of course he made room for Jason. But the room was in the 2 floors down, which is quite serendipitous because it put him next to another virologist at the Vaccine Research Center, Barney Graham. And Barney worked on a virus called respiratory syncytial virus, which causes a lot of morbidity and a bit mortality in human populations. And many parents know because their children are afflicted by it. And although Jason made many important contributions to HIV vaccinology, he realized with Barney Graham that RSV offered a much more tractable system to develop their methods. And so RSV, like the coronavirus you just saw a picture of, has a protein on the surface that it causes fusion of viral membranes. But it's, as they say, a shapeshifter. So if my elbow or arm is a protein, what happens is before it encounters our cells, it looks like this. But when it encounters the cells, it flips open like a switchblade to then stimulate viral fusion and infection. And so what Jason did was he figured out how to stabilize the RSV protein in this stable conformation, which you want your immune system to recognize, because when it recognizes the flipped out shade, it's too late. And in 2013, they published 2 landmark papers where they figured out from the structure how to stabilize it, but also demonstrated that it gave about 20-fold better protection in an animal, in mice, when you immunize it, which is a big breakthrough because people have been working on RSV vaccines since the 1960s. So, and I'm pleased to say just last week, GlaxoSmithKline announced that the phase 3 trials for the McLellan-designed RSV vaccine was successful, and we can expect it to be on the market by the end of the year. Now, that was just the beginning, as you heard. In 2013, Jason moved to Dartmouth, where he and Barney Graham continued their collaboration on coronaviruses, as those of you heard earlier today, specifically the SARS-1 and MERS. And they also figured out in 2017 how to stabilize the SARS coronavirus and MERS coronavirus spike proteins in this highly immunogenic form. So that, as you heard today, when SARS-2 came along, it took them literally hours to figure out how to make the optimal vaccine. And I'm sure that virtually everybody in this room has had the McLellan design vaccine injected to them at some point because it's in all the approved vaccines, Moderna, Pfizer, and Johnson & Johnson. And so indeed, Jason did do basic science with important health consequences. And so I'm very pleased to introduce him as the 2022 TAMEST O'Donnell Award winner. So, Jason.
Wow. Thank you very much, Dan, for that super warm introduction. Dan omitted the fact that he's actually my Ph.D. advisor from Johns Hopkins. So it's always important to have champions in your life, especially in science, promoting you, nominating you for awards. And Dan's been incredible for that. So I'd like to thank Dan for just lifelong enthusiasm for my work in my career. I'd like to thank Nancy Moran, who officially nominated me for the TAMEST Award. I'd like to thank all of the collaborators, colleagues, students, postdocs who helped make all the science possible. You know, the work we do is just really collaborative, right? So trying to create vaccines is sort of crazy. I mean, we're just trying to do one small part, design optimal vaccine antigens, but then there's still the whole thing about delivery platform, manufacturing, clinical trials, volunteers, healthcare workers. So these are really like triumphs of just humanity. And we're really excited about the coronavirus vaccines, of course. 2 weeks ago, we got word from GSK that the RSV vaccines are exceeded primary endpoints, secondary endpoints. And so to help contribute to at least 2 vaccines is really a career high. So it's probably all downhill from here. But I'm going to enjoy it for at least a year or two. I'd like to thank my family, wife, 2 kids for supporting me, help providing some sort of balance to this. And thank you all. It means a lot to me, and I really appreciate it.
Can you get a couple more?
Proof I own a suit, so it's important to document. Thank you.
Very good. Next, I'd like to introduce our second O'Donnell Award winner, Jodie Lutkenhaus. Jodie, I saw you just, oh, you're up here now. I only had a little bit of wine. She is the recipient of the 2022 Edith and Peter O'Donnell Award in Engineering. Dr. Lutkenhaus is the P. Axalta Chair and Professor of Chemical Engineering at Texas A&M University. We'll now watch her video and then learn more about her and her research.
I grew up in a very science-oriented family. It was never a question that I would go into science or engineering. When it came time for me to pick my own major, I chose chemical engineering because I wanted to be like my older sister. The main theme of my research is how polymers can make an impact in our everyday lives and in our future lives. When I first started my career, I was fascinated by how certain polymers could store energy.
We're trying to make a more reliable and domestic source of battery materials, and our goal is to try to do polymer-based batteries.
I imagine this battery that never goes into a landfill, never goes into a trash can.
Trying to make them more recyclable than the current ones too, and polymers offer the potential for that.
The lithium-ion batteries we use today contain metals, metal oxides. Some of these metals can be precious or rare. Some of these metals are mined by children. When I first learned about that, I became really motivated to apply my background in polymer science to make an impact. Let's get rid of those metals. Let's source those batteries domestically from fossil fuels, sustainable sources, biomass, for example, but the point is it's organic.
What really impresses me about Jodie's work is her ability to come up with new ways to apply these materials, whether it's in coatings or as batteries.
What if the battery could be integrated seamlessly into an object such that you never even knew it was there? What if you could create a battery on demand right when you need it? And so that's when I came up with the idea of sprayable batteries and then later graffiti batteries. So you could conceptually spray the 3 battery components on top of each other, cathode, electrolyte, anode, on demand.
That shows really an extraordinary degree of creativity. From where I sit, it's just fun to watch.
In the lab, she strongly encourages us as we're training to think of whatever idea we want to work on or investigate, because she wants it related to her work, but she wants it to be our own.
I wanted to be led either by a woman or a person of color, and because Dr. Lutkenhaus is such a powerful woman, that kind of also really made me want to work with her, because I hope to be like her, or at least even a little fraction of it.
We are the first people to discover this thing in the world. And my favorite part is writing about it and getting it out into the world so that other people can enjoy it.
Dr. Partouche, would you please come to the podium and introduce your nominee?
Thank you. Well, it's a real honor and a pleasure to introduce my colleague, Professor Jodie Lutkenhaus. She's a professor in the Artie McFerrin Department of Chemical Engineering at Texas A&M. She holds the Axalta chair there and has been recognized as a Chancellor's Edges Fellow and a Presidential Impact Fellow as well. Jodie did her bachelor's degree at the University of Texas at Austin and did undergraduate research with TAMEST member Grant Wilson. She went on to do her Ph.D. in chemical engineering at MIT with Paula Hammond, who's an NAE member and a recent Hagler Fellow at Texas A&M. She began her faculty career at Yale before Texas A&M lured her back to Texas. John, that's one you can't take credit for. As you've seen from the video, Dr. Lutkenhaus is really the complete package. She's an excellent scientist. She's a leader and a role model for her colleagues and an outstanding mentor for her students, and I think you saw that in the video. Her work in polymer science and engineering has been recognized with the Arthur K. Doolittle Award of the ACS Division of Polymer Materials Science and Engineering, and her appointment as the founding deputy editor of ACS Applied Polymer Materials. But as I forgot I said in the video, which was shot 8 months ago, what really makes Jodie truly exceptional is her creativity and her ability to recognize applications of molecular level polymer science to create new technologies. You've heard about her work in organic batteries. By understanding the dynamics and reactions of polymers at the molecular level, she developed design principles for metal-free organic batteries that are recyclable and disposable, and that can operate without flammable solvents, which is very important, especially as we think about maybe someday electric airplanes. She's further developed methods for stiffening these battery materials so that they can be utilized as structural elements, which again is critical for lightweighting of whether it's cars or airplanes, the devices in which those batteries are going to be used. And her work extends well beyond addressing one of the things that was not in the video, drug delivery, as well as smart, flexible coatings. I have no doubt that someday we will be welcoming Dr. Lutkenhaus as a member of TAMEST. No pressure there. But for now, please join me in welcoming her to the podium to receive the 2022 O'Donnell Award in Engineering.
Thank you, Mark. Thank you for the nomination. It's really special to be here because many years ago I was a protege, so I was one of the, I think, the 48 proteges sitting here like 6 years ago. But I remember in your shoes watching the O'Donnell presentations thinking, oh my gosh, how am I ever going to be like that? And then here I am, so it's really amazing. So thank you. But I would second what Mark said. I think a big part of being successful is being creative. And you have to find the place that can let you be creative without any barriers. And I think Texas A&M has been such a place for me so far. And so I thank them for my support. And of course, I'm going to thank my husband, who's trying to take a picture of me right now, and our two sons. And I also want to thank TAMEST and the O'Donnell Foundation for this recognition. It is truly the highlight of my career thus far. Thank you.
Very good. Next is our 2022 O'Donnell Award winner in science. Sarbajit Banerjee is the recipient of the 2022 Edith and Peter O'Donnell Award in Science. Dr. Banerjee is the Division Chair in Science and Professor of Chemistry, Materials Science and Engineering at Texas A&M University. Now, let's learn more about Dr. Banerjee and his work.
I find it interesting, the parallels in creativity between different forms, chemistry versus writing versus music, and I think cooking is much the same way. You've got these rules, can you improvise around them and push the limits? My work focuses on the interplay of atomistic structure and electronic structure. For any given composition, there tends to be a thermodynamically favored form. We've been particularly interested in the forms that are not the most stable, which sometimes are only just a little bit unstable.
You have something that's at high energy and then something at its lowest energy state, and so metastable is something in between.
Graphite is the most thermodynamically favored form of carbon, but diamond is also just exactly the same composition, but has a different structure and then entirely different properties from graphite. Just by tweaking the kind of bonding that goes on and where the electrons reside, you can get entirely new forms of matter.
Metastable materials have a wide range of applications. Battery host structures, absolutely. Neuromorphic computing, being able to adjust the electronic properties of extended solids.
So that we can create spikes like artificial neurons that would essentially form the hardware for artificial intelligence.
His research is finding applications in lots and lots of different areas.
A second application that we've been looking at is artificial leaves, catalysts that can split water into hydrogen and oxygen or reduce carbon dioxide into fuels.
We could conceivably use sunlight to split water, and if you can split water into its components, then you have a way to naturally store energy. So it's potentially a very, very big kind of thing.
I have the privilege of leading a group of some incredibly talented scientists who work on solid-state chemistry and materials chemistry.
My goal is to work on science that has impact into the society that we live in right now.
He's really kind of believed in all of us, including myself, before we believed in ourselves. And ultimately, we've really grown significantly as a result of that.
He works on things that have real application in the real world and in the engineering world.
I'm just really fascinated by problems that lie at the intersections of disciplines where you can bring together different sorts of skills and expertise and really take a swing at some big problems. That's what keeps me going.
Dr. Simon North, would you please come introduce your nominee, Dr. Banerjee? Thank you.
Good evening. It really is my distinct pleasure to introduce my wonderful colleague and rising star Sarbajit Banerjee. He's the Davidson Chair in Science at Texas A&M and a professor in both chemistry and material science and engineering. He earned his Ph.D. in chemistry from the State University in New York at Stony Brook, and then moved on to a postdoctoral appointment at Columbia University prior to starting his independent career at the State University of New York in Buffalo in 2007, where he served as co-director of the New York State Center of Excellence in Materials Informatics. It was 2014. We were really fortunate enough to recruit Professor Banerjee to Texas A&M University. He's an NSF Career Award recipient. He's been named a Cottrell Scholar and a NASA Innovative Concepts Fellow. And he currently serves as senior editor for the journal ACS Omega and was recently a senior editor for RSC Advances. What I think is remarkable about him is just his fearlessness to really step off the cliff and engage in sort of scientific studies that I think most of us, at least in chemistry, would probably think, what is he doing? He's also the kind of person that defies definition, at least in our department. Is he an inorganic chemist? Is he a material scientist? Is he an engineer? Is he a physical chemist? And the answer is he's all those things, and I think that's what makes him really special. He's emerged as a leader in developing, I think what you saw today in his talk, novel solid-state and interfacial structures that are really unique. And, as you saw in the video, a lot of these are the same. They all have the same chemical formula, but he's able to sort of do things to them which gives them unique structures and then, therefore, unique function. And his research really spans from the fundamental atomistic level description all the way to devices. He does material synthesis at the atomic level. He does mechanistic studies to understand mechanisms of crystal growth processes and formation of these materials. And he does some really exquisite structural determination and characterization. And it all ends up with him always thinking down the road in terms of how this basic science can be used to make something useful. One example of this would be this class of materials I think he talked about today that changes their properties in response to heat or voltage or light. And so these are sort of very useful devices, and one striking example is smart windows, which I think he talked about a little bit today. These are just vanadium oxide films that he's made so they can undergo this very abrupt transition from an insulator to a metal over a very narrow range of temperature. And so one application is they can block infrared radiation from coming to the, when the exterior temperature is low. I mean, they can allow infrared transmission into the exterior interior when the exterior temperature is low, and therefore provide some heating. But when the exterior temperature goes up, then they become reflective to infrared. And so this provides a really amazing way of having passive temperature control with these materials. And I think what you've seen also in his talk today is it goes beyond just smart windows. He's working in areas of photocatalysis, energy storage, and now making materials that emulate brain-like computation. He really is a wonderful colleague, and he's been a fantastic mentor to his junior colleagues, even though he's junior himself, and also numerous undergraduates, graduate students, and postdocs that have been fortunate enough to make their way through his laboratory. He's received awards in undergraduate research mentoring, graduate research mentoring, the 2021 Stanley Israel Award from the ACS for advancing diversity in the chemical sciences. And it's really remarkable that he's made, at his age, such an impact in pushing the science in his field, but also has made such an impact in training future leaders in materials chemistry. So please join me in welcoming Professor Banerjee to the stage to receive the 2022 O'Donnell Award in Science.
Thank you, Simon, for that wonderful introduction. I'm just so grateful for this distinction and of the work we do in our lab. And as Simon said, when you want to jump off cliffs, it helps to have a parachute. So my colleagues have been my parachute, my support system at Texas A&M, and my role models. And so Dawn and Marcetta Derensberg are here, both National Academy members in the last couple of years, just superb models. Also moved to Texas A&M from Buffalo, and so moving to Texas A&M from New York, it's just been a wonderful experience. And I've really enjoyed, as you saw in the video too, just the incredible diversity of this great state of Texas. And I travel to the Valley, I travel across the state recruiting students for my lab, and it's just such a privilege, such a joy to work with them and to see them blossom into researchers and get jobs and make this economy tick, and it's just such a joy. And I've been, like I said, we've been deeply immersed in my favorite element, vanadium, and the vanadium industry has been supportive every step of the way. And so I'm just super grateful to the industry as well for everything that they do for us. And to George Farr, my nominator, and to all the wonderful colleagues who we collaborate with, because it takes a village. So thank you so much.
Thank you. So last but not least, tonight, it's time to introduce our awardee for the Edith and Peter O'Donnell Award in Technology Innovation, Dr. Ashers Partouche. Mr. Partouche is the program manager of the Aura Intelligent Wireline Formation Testing Platform at Schlumberger. Let's learn a little bit more now about his work.
A blank sheet of paper is an opportunity to let go of your imagination and try something new. To say, okay, well, that's a challenge I have, and let's see what I can do. It's scary. It has to be, right? Because, it's a challenge. I'm an engineer for Schlumberger, and I worked on the Aura platform. To extract hydrocarbons, you have first to figure out where the hydrocarbon is.
There are many challenges in oil reservoirs. Those reservoirs can be 35,000 feet deep. They can be under 1 or 2 miles of water.
These environments that we have to operate within, they're extremes. So many of the things that we had to do on the project resulted in developing new technology.
When you explore oil and gas, you want to understand what are the properties of the reservoir or of the fluid that you are trying to extract.
When you have a discovery in deepwater Gulf of Mexico, for example, or deepwater Brazil or wherever you are, seafloor facilities will be installed. Those seafloor facilities are going to be multi-billion dollars. So you need to make sure that you're designing the seafloor facilities in accordance with what's going to come out of the reservoir.
The Aura platform allows us to reach reservoirs that have a higher pressure, higher temperature, bring in fluid from the reservoir, and with all the sensors that we have built into the platform, that allows us to capture fluid sample from the rock formation and as well as analyze it real time, and then be able to really give this type of information to our customer.
Ashers led the probe design. If the probe fails, the tool fails. The probe had to work.
We connect to the formation and we capture the actual hydrocarbon. We can analyze it and we can actually bring a sample back to the surface for further analysis.
Back in 2015, we assembled the tool for the very first time, and then we put the tool into the well, and the tool performed. It really was a highlight.
You spend so much time building this tool and having a lot of confidence in what it can do, and you turn the tool on or you start actuating the tool, and you see it working, and you see the first fluid coming in, and you see the response from the sensors. It's incredible.
It's been a very difficult time in the oil industry, but the Aura platform was very well received by our clients all over the world, running in all kinds of conditions during this difficult time. It's an amazing success story.
The one thing I always like to do is to have it challenged, and that to me is what really is very interesting about the work that we do.
I'd like to ask Dr. Oliver Mullins to come forward and make a few comments about Ashers.
It's a pleasure to introduce Ashers Partouche and his successes to this community. He's my colleague for 20 years. You can tell who's been there a little longer than 20 years. In any event, the Schlumberger brothers, who founded the company, launched a new industry of wireline subsurface measurement in oil and gas in 1926. It's the founding of this company. Since that time, Schlumberger has maintained a lead in this arena. Arguably the most important and complex of the wireline services is the acquisition of pressure measurement and acquisition of formation oils and other reservoir fluids in the subsurface under extreme conditions. In recent years, Schlumberger launched one of its largest ever engineering projects to build the next generation of this service. Ashers Partouche had become a rising star in engineering with his skills at managing complex multidisciplinary projects and his prowess and his creativity, particularly in the invention of the probe. The probe is the enabling technology which must establish hydraulic communication with the formation fluids and the tool flow line. Under extreme conditions of 35,000 psi, as high as 200 degrees C, and with rugose and variable rock borehole walls. Ashers has come a long way from the island of Reunion off the coast of Madagascar where he grew up. Ashers Partouche was selected to lead this defining engineering effort in Schlumberger, and he and his team performed spectacularly. As fate would have it, this tool service was launched during the COVID times, which was the largest downturn that the oil industry has ever experienced. This is not a good time to launch a new service. In spite of that fact, the tool has been an outstanding success in the marketplace, being run all over the world to address a variety of complex issues for our clients. So Ashers, please come up and receive the 2022 O'Donnell Technology Innovation Award. I'm sorry, I want to mention one other thing. The tool, in industry, often the tool service, not the person, wins the award. And this tool has won 3 awards. Finally, Asher's Partouche is winning the award.
Thank you. Try to not hit the microphone this time. Thank you all for having me and for this award. It's as Oliver mentioned, it's a long way from where I grew up. And when I was in that tiny little French island in the Indian Ocean, I would have never imagined that I would be one day recognized with one of the most prestigious awards of the great state of Texas. So thank you very much. So this, I want to thank Oliver. He has been really a very great supporter of technology development, of pushing the boundaries, and he has been a supporter of this technology, making sure that it talk about it to all the customers that he met, and I'm sure part of the success is due to his involvement. So thank you so much, Oliver. I want to also thank, to develop a technology like this, it's not just one person. I want to thank all my colleagues, my collaborators that work with me on this for many years. We started this over 10 years ago, and it was a long way to come from the pen and paper to get prototype and then test them. And we went through ups and downs, but throughout, we never wavered, and we always thought that despite the difficult industry condition, we have a great technology that could make a difference, and it is making a difference today. I want to thank TAMEST and the Peter and Edith O'Donnell Endowment and Foundation for this award. I think it's a great way to recognize young scientists. And as a science, I would say, my wife would say nerd. I prefer geek. It's really wonderful to see such, an organization that pushes and promotes science. And as far as I can remember, I've always been passionate with science. I wanted to become an engineer, and I was lucky that my parents were able to support me in that desire and help me through my studies, both in France and the United States. So I want to thank also Schlumberger. When I started at Schlumberger, I had no idea what the oil industry was. Actually, I don't know what. It seems very cool when I interviewed, and they hired me, and they put me on a very challenging project right away, and that carried on for 20 years. Maybe that's why I have so many white hair now, but always been very challenging, very exciting. We have a very diverse group of people that can exchange different thoughts and come up with always very fascinating ideas. So I think that's also part of what is the DNA of Schlumberger, and I'm very proud to be part of this organization. Finally, last but not least, I want to thank my wife, Nadine, and our 2 daughters for their support throughout. Sometimes you have to spend long hours at night to discuss problems with across the world because the tool is being used everywhere. And they're always there to support, provide encouragement and share the excitement with me when I was looking at this little graph going at night and seeing that, actually something happened. Maybe they faked it, but they were very happy for me. And also in the more tough time, right? As scientists, it's always not always good. There is always a bit of challenge, and we need support from our family to get us through it. So thank you, and thank you all for this award.
Well, that concludes the awards part of our evening, and what a great group of people. And thank you very much for being here, all of you, and special thanks to the persons who took time to nominate these winners for us. That's really an important part of the process. So let's give them one more round of applause to all of our award winners this evening. So if you are interested in nominating somebody, information on the process is available on the TAMEST website and in the TAMEST newsletter. So please take the time to consider those around you, those worthy of such an award, and nominate them for next year's annual meeting. So tonight you've witnessed some of the very best of Texas. Generosity and creativity, innovation, science, medicine, engineering, and science. We'd like to once again recognize the generosity and forethought of the O'Donnells and their foundation, because they make this possible each and every year. We hope that you'll help TAMEST continue this tradition by considering a donation to support programs and initiatives like the O'Donnell Awards. The staff is ready to accept your contributions this evening. I'm not staff, I'm just a volunteer. Or you contribute online if you would like at tamest.org/support. So this concludes tonight's celebration. The conference program will reconvene tomorrow at 8:30 a.m. here in the Navarro Ballroom for breakfast and our National Science Foundation session with Dr. Panchanathan will begin. Dr. Panchanathan is the director of the National Science Foundation, and Dr. Daniel Reed, chair of the National Science Board. So our delve into great science, engineering, technology, medicine continues tomorrow. Breakfast will open at 8 a.m., but more importantly, the bar stays open until 10 p.m. tonight. Please enjoy the rest of your evening, and thank you for being here, and thank you for your support of TAMEST.